Are virtual machines the only way to virtualize an operating system or application? We've talked extensively about virtualization and virtual machines on this channel, but we haven't really talked about any kind of alternative. In all of the virtualization videos so far, we've talked about applications such as VirtualBox or KVM QEMU, both of which are used to manage virtual machines. Let me ask you another question. Have you ever heard of a container or containerization? What if I told you containerization is another option to virtualize an operating system or application without having to dedicate the same amount of resources as you would when utilizing a virtual machine? Well, it is. Now you're probably wondering what's the difference between a virtual machine and a container. If that's your question, you're in the right place. This is B from TatOG, and today I'm going to be explaining to you the difference between a virtual machine and a container, so stick with me. I have a favor to ask. If you like this type of video and want to see more content like it, make sure to subscribe and hit the bell button for notifications. Also, don't forget to give this video a like if you liked it. Let me know what you liked, didn't like, or if you have any comments, questions, concerns, or emotional outbursts down in the comments below. Lastly, stick around all the way to the end to get the most out of this video. Let's do this thing. All right, so let's go ahead and get down to the desktop. I've got a little visual here for you so we can see the difference between virtual machines and a container. All right, so let's start with virtual machines because we've covered these extensively on this channel. Now, a virtual machine is basically a virtual computer. It will look the same and sound the same for the most part to every other system and every other device on the network. A virtual machine emulates computer components in software and can pass devices directly through to the virtual machine by using, but are still connected to the host machine. Now, virtual machines run on software known as hypervisors, and there are two types of hypervisors, and I'll kind of go over this in the visual here in just a second. Type 1 is an operating system dedicated to run the virtual machines. Now, think Proxmox or VMware's ESXi. And then type 2, it runs on top of the operating system. So think of something such as VirtualBox or UTM if you're using Mac. Now, in a virtual machine, you can run any host operating system. You can run Linux, you can run Mac OS, you can run BSD, Windows, anything that your heart desires. Now, one of the biggest pros of a virtual machine is the fact that the virtual machine is separate from the host operating system and any other virtual machine, so you have that segmentation there. Now, one of the biggest drawbacks is the amount of storage that can be required for the virtual machines, at least compared to containers. The file size, you're going to be looking at pretty much the exact same size as if it were running a full-on desktop operating system. And we look at some of the Linux distros out there. Those are small, maybe 4, 5, 6 gigabytes. But then you compare that to Windows, which is, I can't remember, it's like 20, 30, 40 gigabytes that are needed just for the operating system. Mac has also got quite a bit to it, so just keep that in mind when you're running those in a dedicated virtual machine. That's going to be storage space used up on the host operating system. Now, let's go ahead and talk about a container. Now, a container is a lightweight package containing all the required dependencies to run a single application. So really what it is it's a standalone application. It shares resources with the host machine, including the kernel. They run on top of software known as a container engine. And the most common types of container software that are out there in platforms is Docker/Podman. Now, Podman was basically Red Hat's clone of Docker. I put those together because they function essentially the same. So, yeah, just know that. And there's also LXC, which is Linux containers. There's also like a front end for that from Ubuntu. I should say Canonical, which is called LXD as well. And those are two things that I may cover. And all three of these are things that I would like to cover in the future. So make sure you're subscribed for that. Now, when it comes to a container, the type of operating system does need to be the same as the host operating system. So if it's a Windows system, it's going to have to be Windows. If it's a Linux system, it's going to have to be Linux. Now, keep in mind that I've so far, when we're talking about containers, have really only emphasized the application aspect, but you can run an operating system, a full operating system directly through a container. So keep that in mind. Again, it's just going to have to be the same one that you have as the host operating system. Now, one of the biggest pros for containers is they are lightweight. That makes them fast, and they take up small amounts of disk space compared to a full-on virtual machine. Now, a big con for them is that they share the same OS and hardware as the host machine and could be impacted by issues in the host hardware or OS. Technically, a virtual machine is kind of doing the same thing, but it's also, it's just a little bit different in the way that it does that. So I just wanted to point that out. Now let's talk about this visual, because I wanted to show a couple of things here in regards to this. So I wanted to show the difference between hypervisors and containers, but also the different types of containers, because I do find it a very interesting parallel. Now, the type 1 hypervisor is basically a box that's going to be dedicated solely to the management, and support of virtual machines. Now, if you've been on this channel for a while, you have seen this system right here. Or this is my test server that I have at my apartment, and it is running KVM and QEMU. So KVM is technically a type 1 and a type 2 hypervisor, because really this system can be used for anything. Now, I consider it a type 1 hypervisor because I don't use this. I use this primarily as a server, and the stuff that typically I'm putting on here is usually going to be virtualized, but, it really is just going to be up to the person, because, even though I have other services on there, you can make the case that even if you're looking at, other types of, systems out there, look at Proxmox, which is a type 1 hypervisor. You can set up all sorts of containers and all that kind of stuff. Now, it is dedicated solely to virtualization, but the lines are just crossed. So some people may say that my server is a type 2, and a type 2 basically means that the hypervisor runs on top of a host operating system. That would be something in the case of in VirtualBox or UTM. I'm on a Mac here, so this right here is UTM, which you can kind of consider like a peer or similar software to VirtualBox. But yes, this is UTM. This is a type 2 hypervisor, and we can see here the type 1 is it's going to have the hardware, it's going to have the hypervisor software, and then it's going to have the virtual machines right on top of that. It's definitely going to be more specialized. Whereas when we do a type 2 hypervisor, we're going to have the hardware, we're going to have the host operating system, and then we're going to have the hypervisor on top of that, which again is going to be VirtualBox, UTM, QEMU, KVM could also be included really in there. Now, we can see here that this is actually very similar to the way that we visually represent a container. Now, a container is going to be the hardware, the operating system, which can be Windows, Mac OS, Linux, and then the container engine. Think Docker, Podman, or LXC. And then on top of that, you would have your actual containers. Now, let me show you something here, because here we actually have my Debian KVM virtual machine. So this right here is a virtual machine. And then on this one right here, this is actually a container running inside of my virtual machine. So yeah, we're running it inside. We're like, some Inception stuff going on here. We've got the virtual machine running a container, but really they're both the same thing. Now this is actually a Kali Linux container. So you can actually go to Kali's website and download a container and then run it as its own standalone container on your system. So here in this case, we're operating we're doing a actual host. Now we're actually doing an operating system. Now keep in mind that there typically are going to be limitations built into that, so you may not be getting the full experience of an operating system without other configurations. So just keep that in mind when you're talking about running a full-fledged operating system in a container, that it may require additional configuration. Like for example, when you download the Kali container, you do need to add a lot of the tools and stuff like that on top of it. So it's really a bare bones. Like let me show you something here. Like I run IP address, and it doesn't find that. So I'd have to have pretty much everything installed on this, as if I were, installing, something from scratch. Now, all right, cool. Containers are a really cool technology and make spinning up new services super easy. I do plan on covering more containerization content in the future, so make sure you're subscribed to that. Make sure to check out the other videos in my virtualization playlist. If you're caught up on that, check out this other video from my channel instead. Remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.